Good morning. Uh, so, in the previous session, we have studied about the number system. Okay, in this number system, we have different types of number system. In that, we have seen what are decimal numbers, then what are binary numbers, and how to convert binary to decimal. Okay, so in this today's session, we will see how to convert a decimal number into a binary. So, these are the different types of number systems: decimal, binary, octal, hexa. You know what is radix. Then these are the positional weights. Yeah, this was decimal number representation and this was binary number, binary system. So, binary positional weights. This was a thing which we have seen in the previous video. The thing is, we converted a binary number 11101 to a decimal number. So, after converting, the result what we got was 29 in decimal. Okay. So, now the next thing what we will do is, and yes, we have also given you few practice questions. Okay, if you have done these, and then that means you are well practiced on these conversions. Yeah. Now we will try to convert from decimal to binary. So, to convert from this decimal to binary, why do we first of all convert from decimal to binary? See, before we have seen binary to decimal conversion. Binary numbers we do not understand, it's all are like 01, 01, 01. So, for our understanding we will convert binary to decimal, that means for user understanding you can say. Okay. Now, coming to this decimal to binary, I am converting this. Actually, why do we do that is, the basic thing what we need to do is, these days every day everything is digital. Okay. So, we generally in surrounding us everywhere you see we have machines around us, okay, the gadgets around us which take a digital data. So, that means a machine, the processor, whatever inside that machine, okay, let it be a processor or a controller, it will understand only the machine level language. Okay. So, the machine level language means, machine level language means 0, 1, 0 and zeros and ones, okay, nothing but binary bits. This is the machine level language. So, even though if I am speaking in some English language or some other language, or whether my input is in terms of some music, take this voice, I'm just trying to explain you this slide. So, while I'm trying to explain, what is happening is the voice, my voice is the input, okay, and that voice is going into the microphone of my device, okay. In that device I have a microphone where my voice is been going into that, where that it converts, that microphone converts my voice signal into a voltage, nothing but electrical signal. Is that fine? And that electrical signal is I mean that electrical signal will be gone into that machine. Before processing itself, that will convert that voltage levels to zeros and ones. As I said in the previous videos, if you consider a VCC, okay, I have just taken a square wave to represent 1, that means VCC. Okay, the supply is, if the IC supply is 5 volts, then that means at 5 volts my binary digit is equal to 1. If I have a 0, that means ground. Okay. So, in that way my data can be transmitted. If I am trying to save any pictures, any images, or any movie, any songs, everything, whatever I am trying to save, that won't be saved in the format what I am trying to do, whether you are trying to save it on a CD drive or floppy, which we used to use previously. Nowadays we have drives, okay, pen drive, hard disk, your hard drives, and Blu-ray, okay, such things. So, in this whatever the data is there, it is stored in the form of zeros and ones, which we call it as machine language. Okay, we can also call it as low level language. So but that machine language can't be understood by us. Okay, that is very difficult to figure out. It will be very complex to write. So that is the thing. To communicate with the device, I wanted to convert that binary to decimal and decimal to binary. Okay, because I can understand decimal, but machine should understand, even machine should understand. And when machine is giving me something that will be represented in the form of binary, again I should understand the output whatever is given by the machine. That means again that binary term should be converted into decimal. Is that fine? So these conversions we generally see. Yeah, so it is necessary to convert this decimal number into binary to make computers to accept, nothing but just to accept my data whatever I am trying to give, and whatever output the computer is giving I will try to read that, okay, in a different format other than low level language. So we will just see how is that done. See, in this method there is a flow chart here. Okay, so in this you just see, in this method the decimal number is repeatedly divided by 2, okay, till quotient becomes 0 with remainder 1. So this is very simple. We just need to divide, okay, divide the this decimal number. Okay, we are converting from decimal to binary, right? So we just need to divide, keep on we should divide that decimal number till when, until we get quotient as 0 and remainder should be 1. So we just go on, we keep on do this. Okay, if you don't get a remainder 1, then you again need to divide it by 2. Why are we dividing only with 2? Because I am trying to convert decimal to binary, and binary's base is 2, binary numbers base. Okay, that is the reason I should always divide it with only 2. Whatever, if I take a number 16, okay, if I want to convert the 16 decimal number, see, let me do here. If I want to convert this 16 decimal number into binary format, this 16 to the base 10 here. Okay, this I will try to convert to binary. So I will just do with 2. So what will I get when I do 2? I will just get, yes, how many times? So here this can be divisible by 8, and remainder, what is the remainder? So there is no remainder, I mean 0. So but sorry, quotient is 0 and remainder is 8, but I want my remainder to be 1. So again I will do with 2. So when I do, I will get remainder as 4 and quotient is, sorry, yeah, 2 4s are 8 and 0. Then again I will try to divide with 2, then I will get this place won't be sufficient. I will write it in a smaller 4. When I write it 4, 2s are 2, 2s are 4, remainder I mean 0. Then again this 2 will be divided with 1, then here again it is 0. Is that fine? So these are the things I got. See, here I got 0, 0, 0, 0, and here remainder is 1. So whenever I try to write in the binary, you should always write from down to upwards in this direction. Okay, down to upwards. Take these bits 1 0 zeros. So what is this remainder here? I have 1. Okay, so first I will write 1. Then I have 1 2 3 4, 4 zeros. Okay, 1 2 3 4. So this is the binary form of 16. 16 is a decimal. This is 2 to the base 2. In this way you will convert it. Okay, we have it in a clear format further. So for this you just see the flow chart. Whatever I have done, that I have done that because you can easily understand this flow chart. See, first you first of all, whenever we write a flow chart, when we begin we will write start. Okay, then we will end it once we end. So this start and end. So after starting we are dividing by 2. Okay, after dividing that decimal number with 2, Next, see, record the quotient and remainder, whatever I have done here. Okay, so I have recorded the quotient, then remainder. Then after that, what I am going to do is, I should check whether my quotient is equal to 0. Yes, see here, this point, I should check whether my quotient is equal to 0. If yes, then I should collect the remainder into the desired binary number and first R as LSB. So the least I am trying to write from the downward down to upwards, right? So that downward should be my MSB, and see, I have written in this direction, right? So whatever the remainder here I had, that will move into MSB. See here, this term, the uppermost term, whatever I am getting, it should be my LSB. So that is what he is studying here. Okay, so see, into a desired binary number with the first R as that means first remainder. Here, whenever I try to solve it, the first remainder what I get, that will be LSB. Okay, and the last R means last remainder is this one 1. So that remainder should be MSB. After that, end. Okay, so this is when quotient is equal to 0. But what if I don't get a quotient is equal to 0? Then it will just go back and it will start. Okay, that means what it does, see, I have taken 16. Okay, so first time I have divided, so 2 8s are, and remainder was 0. Okay, but here this quotient was not equal to 0. When this quotient was not equal to 0, what will I do is, see, first this step was executed. Now this quotient is not equal to 0, here I got 8 instead of 0. So what will I do is, instead of stopping here, I will again go back, means again I will divide by 2. Again I will divide that by 2. After dividing that by 2, again 2 4s are 8. So here remainder is 0. Okay, so once that is 0, then again I will check my quotient is equal to 0 or not. It is not. So again I will divide it with 2. Again I will get a remainder 0. So again this is not equal to 0, again divided with 1. Okay, so in this way I keep on do, and see, this is the last remainder what I get. Okay, yeah, this is the last remainder what I get, and this is the first one what I get. So here yeah, whenever I am getting this, so this I will consider it to be as LSB, and this I will consider it to be as MSB. Is that fine? So this is nothing but the flowchart explanation of the way you convert from decimal to binary. See, find the binary equivalent of decimal 25. He has given 25. So see, division, quotient, remainder, that is what we are going to do. So just divide 25 by 2. So quotient you will get is 12. So it is nothing but the same format what I have done. See, take 25, 2. Okay, because you are converting it to binary, so binary's base is 2, so you are dividing it by 2. So in this 2 12s are, you will get 24, but here you have 25, so remainder is 1. See, remainder is 1 and quotient is 12. Okay, is that fine? So now again here what you are going to do is, see, next again you will just divide it with 2 again. So 12 means 6 remainder is 0. So quotient is 6 and remainder is 0, that is what I got. So again I will divide it with 2. Okay, till I get all zeros and ones, I keep on do that, because I can't write 6 0 1 right in binary. Yeah, so yeah, 2. Then again if I divide 3s are 2 3s are 6 and there is no remainder. Okay, so I will get this as in this way. Next again here I will divide it divide it with 2. So 2 1s are 2. Okay, 1s are 2, remainder 1. Is that fine? So now when I write, I should write from down to up. Okay, down to upwards. So this is my MSB 1. See, this remainder here I have is 1. So 1, then again here also 1, then 0, 0 and 1. This is LSB. So this is the binary value 2 to the base 2 to the decimal value of 25. If you want, you can just check. See here, what do I have is, I said 110, this is what I got, right? Okay, is equal to 25 of 10. So how to check is, see here, this is 16, this is 8, 4, 2, 1, right? So see, 1 and 1, place of 16 and 8 you have, then at place of 1 you have, just add them. 16 plus 8 plus 1, you will get 25. Is that fine? So this we have done. So that is what he is telling us here. So next is dividing with 2, again I will get remainder 1, then again 1 by 2. Okay, this is LSB. The remainder is 1 here when you divide with 2. So, and the quotient will be 0. Is that fine? So see, in the LCM whatever I have done, I didn't do that last part. See, whenever you just do LCM with 2, you will get 0, because if it is lesser than the value what you are dividing, then that is nothing but your 0. So this, when you got this in this direction, you will write from downwards to upwards. Okay, this is MSB and this is LSB, and that will become your binary number. See, find binary equivalent of decimal 25. Okay, this we have just done it. So he is just representing each remainder. So this is first from LSB you are trying to write. LSB is 1, then the next is 0, then other is again 0, then 1, then 1. 25 is equal to 1. If you write in this way, even though you are doing correct, you won't get a proper marks. This is not a proper way of representing it. So whatever the question they might be given, if you see a decimal 25 value, whenever they write decimal 25, that is fine. If they don't write anything, that means you should write at your end of your solution 25 to the base 10. You should represent it in this way, because that is decimal number, is equal to, you should also write 11001. If you write in this correct representation, only then you will get full marks. Okay. See, the answer is read from the last remainder and up as shown by the arrow. Now there are a few examples. We have done the equivalent of this decimal 25. The other example is for 125. So the 125, see, 2 62s are, I got 124. Okay, in this 125, one is remaining. Okay. Oh, yes, 1 second. Yeah, we are on this slide. So here 62. Okay, remainder is 1. He has written here. Next, after that, 2 31s are, you got 62. So 31 is your quotient and 0 is your remainder, because 2 31s are 62. There is no remainder. Next, 3 15s are, okay, 30. So once you got 3 15s are 30, but the number is here 31. So 1 you got as a remainder here. Okay. Next you got is 15. You need to divide 15 with 2. Okay, 15 with 2. That means 2 7s are 14. So when you get 2 7s are 14, the remainder will be equal to 1. Okay, so see, don't get confused. The remainder we are writing at these positions. These all are the remainders. Okay. This is the remainder of this 7. This was at 125, 262 you got was 124. So, remainder was 1 you have written here. So, for 62 there was no remainder. So, it is 0. For 31 you got a remainder 1, that is here. For 15 you got 1 as a remainder. For 7 you got 1 as a remainder, that is here. Okay. So, next what will you do? 2s 2. Again you will get a remainder. Is that fine? So, that means see in this way. Again you got a remainder. So, you can directly write in this. You can directly write instead of dividing it again with 2. You can also directly take this one, because if you divide it with 2 again, anyways you are going to get 0 here. Okay. So, you can directly write from this 1 here. In this one remainder you have written here, and in this way you are writing. See, you can also consider 0. If you consider 0, you will get as 0 1 1 1 1 1 0 1. Is that fine? So, if you do not consider this 0 also fine, because as I said you in the previous video, left side of any left side of this bit integer part, you need not consider zeros. They make no sense. Yeah, excuse. So, even if you do not divide it with 2, that is fine, you can directly write the answer, that does not matter, but this is a procedure which you need to follow. So, he has written, see, this 125 is equal to, from here first he has taken this LSB 1 as here. Okay, the first remainder is as LSB. Next 0, next 1 1 1 1, in that way he has written. Okay. So, all what we saw was about the decimal numbers was in the previous video. In this video we have seen the conversion of decimal to binary. Okay. So, in the next video we will learn about octal and hexal systems, octa and hexa. So, if possible, you try to find this equivalent of 110. Okay, decimal equivalent of 110. That means here what I am trying to say is, this is not a decimal value, this is a binary value. What I have given here is, this is binary value. So, I am asking you to convert it to 6. Is that fine? So, if you can try, just try it. Okay, pause this video and try it on your own. So, after trying, when you resume this, just see the procedure. In the previous video we have seen this, how to convert binary to decimal means I have already said 1 1 0. So, positional weights 2 power 0, 2 power 1, 2 power 2. 2 power 0 means no need of taking this, because this is 0, 0 into something is that. So, instead of that you can also, even if you consider, just see here you have 1. So, 1 into 2 to the power of 2 means 4, okay, plus this one again, this one is done. Next this one into 2 to the power of 1, that is 2, plus this is 0 into 2 to the power of 0, that is 1. Okay. Now, that is equal to 1 into 4, you get 4 plus 1 into 2, 2 plus 0 into something is 0. So, the answer you are going to get is 2, 4 plus 2, that is 6. Is that fine? So, this is the answer for your decimal equivalent of 110. So, after completion of this solution, as I said previously, you should always represent in this format. The binary number 110, so to the base 2 will be equal to 6 to the base By this you will complete your conversion. Okay, so in this the small thing what we do is you have converted from decimal to binary and binary to decimal, the conversion patterns you have seen. So before going to the other types, I'll just discuss how we generally write the numbers. First of all, whenever you say binary, that means you have whenever you say decimal, that means you have 10 symbols in that, so 10 digits in that. Okay, 10 digits, that means it will start from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, these are the decimal, nothing but total it has 9 digits in this. Is that fine? Next, coming to binary, it has 2. Okay, that is 0 and 1 in that, it has only 2 symbols in that, that is binary. Next, coming to octa, it has 8. Okay, so 8 means that starts from 0, 1, 2, 3, 4, 5, 6 and 7. So 0 to 7 means total you have 8 digits in this octa. Next you have hexadecimal. Okay, hexadecimal means you have 16. So 16 means starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 9, that means after 9 you will be having 10, 11, 12, 13, 14 and 15. Okay, 0 to 15 it will make you 16 digits of hexadecimal. But in this hexa, instead of writing 10, okay, instead of writing 1, 0, 10, what you will represent that value is with A. Okay, A means 10. Next B, C, D, E and F. Okay, so this is 9. After 9 you will have 10, 11, 12, 13, 14, 15. So in this hexadecimal I am writing after 9 it will start with A and end with F. Okay, we will write A, B, C, D, E, F. Instead of A, if you write 10 over there, that will become a decimal number. Okay, instead of 10 if you write A, that will become hexadecimal number. So here these are the basic 4 types of the number systems. So this you have 10. Okay, here you have 10 digits in this decimal. In binary you have 2 and in octa you have 8 and in hexa you have 16. So you can easily identify by checking these values. If they give you some question, you can easily know if the number is from 0 to 9. You may get confused, okay, between hexa and decimal, because even in hexa you will have 0 to 9. Okay, is that fine? So is that hexa or is that decimal, you might get confused. So for that reason, to the base you need to mention, if it is decimal you need to write 10, if it is hexa you need to write 16. Okay, and if it is between 0 to 7, 0 to 7 you might also get confused with this octa, because you don't know whether, if you don't write any base and if you have a value 26, now you don't know this value is either decimal or octa or hexa, you don't even know, because there is 2 in decimal, 2 in octa and 2 in hexa, and there is 6 in decimal, 6 in octa and 6 in hexa. Okay, this is definitely not a binary, because binary has only 0 and 1s, but this 26 we don't know. So by mentioning the base to this, you can mention whether it is decimal or octal or hexa. Okay, so, and here one more thing is, if in case if your question, if they might give you like alphabets in this way, A to 6, okay, in this way if they give you, definitely this will be hexa, because you have alphabets only in hexa, that is A, B, C, D, E, F, you definitely have in hexa. Is that fine? So by that you can easily say that is an hexa value. And in case if they give you a number like 82, so if they give you such numbers, or 28, whatever it is, both in both the cases, by checking this you can easily say this number has this number can be either decimal or hexa, but it can't be octa, because just check in octa, it starts with 0 and ends with 7. There is no number called 8 in octal. Okay, so in this number if you have only 0, 1, 2, 3, 4, 5, 6, 7, 8, only between those range, then only you will consider, you will have another doubt called that number can be an octa as well if they don't mention a base. But generally they will mention the base, or else they'll, if they don't mention a base, they'll say the octal number and they'll give you so and so number. Is that fine? So I'm just trying to say this because you can easily identify the difference between this decimal, octa and hexa. So always octa has the 8 digits from 0 to 7. Next, hexa has 16, decimal has 10, and also you need to remember this. And in this binary, if you consider this binary, you can write this binary in terms of decimal, hexa or octa, in whichever you want, but you need to have convert. For now we have just studied the conversion of decimal to binary and binary to decimal, that's it. So this binary can be also converted to octa and hexa in the both the ways. Okay, you can convert that, we will see in later. But whenever you wanted to to write in terms of octa, okay, so whenever you want to write in the term of octa, what you are going to do here is you need 3 bits. If you want to write in terms of octa, you need 3 bits to write 0 and 3 bits to write 1, 3 bits to write 2. We don't require 4 bits. Even if you take 4 bits, this bit will be 0 for all the numbers, because in octa you have only 1 to 7 and the minimum value is 0 0 0 and the maximum value is 1 1 1. This is for 7. Okay, so if it is more than 7, then you require the other bit. The value for 8 is 1 0 0 0, right? So this is not required for octa. So to write a values in binary for an octa values, you require only 3 binary bits. Is that fine? That you need to remember. Next, if you want to write for hexa, okay, if you want to write for hexa, you definitely require 4 bits, because here it is not ending at 7, it is ending at 9, then 16. Okay, 16 means, see, 2 to the power of 0, 1, 2, 3 and 4. So you require this other bit as well. The maximum value will be 1, sorry, 4 bits, already 4 bits are there, yeah. See, 1, 2, 4, 8. So when you add all this together, okay, you will get this f term, that is your 15th term. Okay, so total 16 bits will be there, including 0. If you include 0, it will become total 16 bits, but it will end at 15. 15 means you will generally have f, f, f and f. Okay, if you write it in binary, then you will write all as f's. I mean, it will become 1, 1, 1, 1 and 1 in all ones. Okay, so this in this way you are going to represent your binary in terms of octa and hexa, and in terms of decimal it depends on the value. So whatever the value increases, that much you keep on increasing the value, same like this hexa. If you have only up to 7, then you can write in 3 bits in that way. Okay, if you have more than 16, you need more bits, 5 bits, 6 bits and so on in that way. So these are the binary numbers. Yes, the small thing, the other thing I didn't discuss is this also you try to solve on yourself. What I spoke was in all these slides there was a number 110. You have solved it, but what if you have a number 11001 here? Okay, so for this you have done an LCM, right? You have divided. So to this what you need to do is you need to multiply. After point you need to multiply it. Is that fine? So for this we have, this is your binary number. You wanted to convert to decimal. Okay, for binary to decimal the procedure is different, for decimal to binary the procedure is different. For decimal to binary you need to divide it. Okay, so first we will see binary to decimal. Binary to decimal means consider 11001. If you take this, I am not doing the whole sum, I am just giving you an idea, try to do that. See, this is 110. 110 means you have already done for this, the positional weights, how you have done this, you have taken 2 power 0, 2 power 1, 2 power 2. So you have just multiplied with them. Here what you need to do is point, here you will get 2 power 0 means here you will get 2 power minus 1 and here you will get 2 power minus 2. So just multiply them. So 0 and 0, these terms will just be erased, and this 1 into 1 by 2 to the power of minus 2 means after point. Before point we have already done 110 the number. So just solve this and that will be your decimal value. Is that fine? So this is your decimal value. So you will get 0.5 here. This was 6. Okay, so here this side you will get 6 and here you will get, sorry, so here yeah, so this you will get is 0.5. so that means this value is 6 and this is 5, 6.5. this is the binary value for, this is the, sorry, decimal value for this binary value. Okay, so after the point, before the point, how to calculate? Now same way, if you have a decimal number, okay, the same number will take, you have 6 point, sorry, not 6.2, what we got was 6.5. okay, you got 6.5. so for this what you need to do is, here you will do this side, left side of the decimal point you will just do the LCM, I mean division method, and this side you will just multiply, okay, with 2. This side you will divide and this side you will multiply with 2. So you will get an answer for that, the same procedure again. So you need to follow that. Yes, so by this we'll end the class here. So in this last two videos we have seen types of know what is a number system, then types of number system, explain a binary number system, then perform the conversion from binary to decimal and decimal to binary. Thank you.